Welcome to topic 3 of data science, and this topic has 3 subtopics: storing and managing data, cleaning and reduction, and data formats. So, first of all, storing and managing data, and I've just put this quote in here just to remind us that the main focus of data science is the extraction of knowledge from data. And we extract that knowledge to try and generate insights so that we can take actions based on those insights. So, the first type of data storage we're looking at today is network attached storage. Now, network attached storage is a popular choice for the storage of big data, and network attached storage is actually quite easy to set up. So you could set up a network attached storage device at home, and really it would just be a computer. You could do it with a Raspberry Pi with a hard drive connected to it that you store files on. Okay, now sometimes you can get a thing called a NAS box, a network attached storage box or storage device, and this is really just a computer with a few hard drives in it that you can store. Now, these often use file sharing protocols such as the Network File System. SMB, I think, stands for Server Message Block or Secure Message Block. I always get those two mixed up. And AFP is an Apple protocol, the A being the clue there. So the key thing to understand about network attached storage is that the storage takes place at the file level. So it stores files. The next type of storage is called object storage. And object storage stores things or data as objects. So in contrast to storing data as files, you store data as objects. Okay? Now, each object has the data and some metadata about the data. So when we think of metadata, think of when you receive a letter. On the front of the letter will have your name, your address, maybe on the back might have where it came from, return address, postage stamp. All of that kind of stuff could be considered to be metadata because it's information about what's actually in the letter. So just like in networking, we'll have metadata about a packet, like source and destination IP address and things. Metadata is data that's about what's actually contained in there. So some globally unique identifier and some metadata, and then the object itself. Now, object storage is used by large-scale organizations such as Facebook. Songs stored on Spotify are stored using object storage, or files stored in Dropbox are stored using object storage. So the next type of storage is called block storage. Now, blocks, which are sometimes called physical records, are just sequences of bytes. And this is the lowest level of storage. So when we store things in blocks, we're storing them in, you could consider these to be binary sequences and actual blocks. So for disk devices, blocking will reduce the amount of storage required for the data because it's quite a raw way to store things. So blocking is universally employed when you store data to flash memory and floppy disks. If you've ever saved something to a floppy disk, unlikely you've ever done that, but if you have, and CD drives as well. And we use a command called dd in Linux, and dd lets you create a raw copy of a disk. It copies it across. So if you're ever imaging a Raspberry Pi, you could use the dd command. Although there are some easier tools to use, but if you don't want to use the command line, there's a tool called Win32 Disk Imager that runs on Windows that's good for doing that. So those are the 3 types of storage. There's one more, and it's called software-defined storage. And it isn't really a type of storage, okay? Software-defined storage is just a marketing term. Okay, so a company like VMware or Microsoft might say to you, oh yeah, we have a software-defined storage platform. Okay, it's just a marketing term. Okay, it can be hardware, it can be software, it can be something that a company sells. So here's a graphic that represents these three types of storage. So here we have file storage, okay, network attached storage. Actually, you can see that we have a hierarchy of folders here. Okay, so you might have my films here, my movies, and you might have action movies, cartoons, anime, some other genre, romantic comedies over here, and then in your romantic comedies you might have subcategorized them into different levels of emotion and so on. Okay, you might have your Richard Gere ones here and your Tom Cruise ones over here. I don't really know. Network attached storage is file based. That's the point. So underneath the file system, we'll have this disk where we actually have raw bits, and those are the blocks used by block storage. And then this third type is we have some kind of identifier here, and then we have data stored as objects. Okay, each object has an identifier with some metadata. So object storage is closer to block storage, and file storage is the kind of highest level. And probably this would definitely in fact be the easiest one for you to set up at home. Okay, so those are the 4 types of storage we need to know about. Remember, software-defined storage is just a marketing term. These are really the 3 types of storage we need to know about. And when we talk about file storage, often we talk about network-attached storage. So the next subtopic is called cleaning and reduction. So cleaning and reduction. First topic in cleaning and reduction is non-transactional data. So to know what non-transactional data is, we need to know what transactional data is. Transactional data is something that has a time dimension, a timestamp. So probably the easiest transaction you could think of is like a payment, a financial payment, an invoice, an order, something that has an order ID and a timestamp. A social media post is a transactional piece of data. Things that are non-transactional generally last for a longer duration. So a customer's name, customer's account number isn't really transactional data. They're not going to get a new account number every time they place an order. The location of an office is non-transactional data. So we need to know the difference between transactional data, non-transactional data. Data auditing is the use of statistical and database methods to detect anomalies and contradictions in data. So just like in network security, we can do different kinds of audits, security audits. We can do a data audit, and we can go through data and look for poor quality records or corrupt records and find out if that data is fit for purpose. And that process is called data auditing. Now, let's say we found a lot of data that wasn't great. We can use this process called data scrubbing. So data scrubbing, data cleansing, data cleaning is the process of detecting and correcting or removing corrupt or inaccurate records from a record set. So data cleaning, data scrubbing, data cleansing, they all mean the same thing. So let's say we have 100,000 records, and we go and look at these 100,000 records and we realize that 400,000 of them are corrupt. In the data scrubbing process, we would scrub those records, get rid of them, and then we would have 600,000 good records, okay? So the data auditing process can be looking at the data and finding out if that data is fit for purpose, what records we have. Then the data cleaning process or data scrubbing is getting rid of records that we don't want or correcting them. Okay, so after cleaning, a data set should be consistent all the way through, so we should have a uniform data set after the data cleaning process. Now, another process is called data munging or data wrangling. So data wrangling is taking data from its raw form and then structuring it. And there's an actual name of a job, okay, a role, and that is a data wrangler, okay, with a silent W. It's a person who performs transformational operations. And I've got a little graphic down here. Imagine we have all this cleaned data here in these, the green, the orange, and the blue category. The data wrangling process would sort that out into two separate piles. Okay, so let's say some data comes in a raw format, and it's not perfect to use. Let's say it's all in Word documents. We might want to get that into the format that we want to work with, into a JSON document or into a CSV file that we can then perform some analysis on. So data munging or data wrangling is the name for that. And the last topic of this process is called denormalisation. Now, denormalisation can also be spelt with the Z if you're using the spelling from the United States of America. Now, to know what denormalisation is, you need to know what normalisation is. So normalisation is a process by which a relational database is structured, and there is a different set of what are called normal forms of data in order to improve the way that data works inside a relational database. So there are things called first normal form, second normal form, and if we look at let's do data normalization. There it is there, database normalization. So database normalization was created by, initially in, I think, the 1970s by this chap, Edgar F. Codd. There he is there. Sadly passed away, 2003. And he was known for, he invented a thing called the relational model for database management. Okay, so normalization, we can satisfy a thing called first normal form. And to understand that, if we had some data in a table like this, okay, to satisfy his conditions of first normal form, we would turn that into separate tables, okay, like this. Now, these separate tables could then be accessed by a relational database. Now, there's a thing called second normal form, where we would have a table like this and turn it into this, and there's a third normal form as well, and there's a fourth normal form as well, and an ETNF. So understand that database normalization is quite a big subject in itself. But what we need to know is what's denormalization. So denormalization is the process of undoing a normalization. Now, denormalization is a strategy that's used on a database that's been normalized. So we can improve read performance of a database at the expense of losing write performance by adding redundant copies of data or by grouping data together. So if I just do an example of a relational database, okay, relational database, let's look at an image and see if we can find a graphic that shows a relational database that's laid out relatively well. So here's a good one. Let's see if this is what sort of resolution this is. I don't want it to be a horrible resolution. All right, so here is a relational database with some tables. We've got ratings, users, tags, ID. Now, if we wanted to denormalize this database, we could just have 4 tables and have everything in all 4 tables. And that would make our data lookups much faster, but it would be a lot less efficient. So that's denormalization, the process of undoing database normalization. And it doesn't matter if we add redundant copies of data. It doesn't matter if we lose write performance. The whole goal of denormalization is to speed up the read performance of a database. So those are the kind of 4 subtopics. We have denormalization, the process of undoing a normalized database, data munging, or wrangling, taking raw data and making it structured, data scrubbing, cleaning out or correcting old records, and data auditing, having a look through the data and finding out, which parts of the data are fit for purpose. So those are the topics there. The last subtopic today is about data formats. So what format do we have data in? Do we have it in the form of a screenshot from a phone? Do we have it in a Word document? Do we have it in a JPEG? So a common format to use is a format called JSON. Okay, and JSON is short for JavaScript Object Notation. If you've ever seen data laid out like this with curled braces, and then we have key value pairs delimited by colons, and the pairs delimited by commas, and we can also have nested arrays inside of pairs, this format is called JSON. Okay, now JSON is useful because if I give you a JSON file, Python or R or most programming languages, Perl, will have libraries that will allow them to read the JSON. So it's a useful format to allow interchange of data. Now, it's also used in document databases. Another format is XML. So XML is the extensible markup language, and XML looks very much like HTML. You have tags, just like you have in HTML, that open and close. So in this case, we have a root tag that opens and closes here. Then we have products. Then within products, we have individual products that have a code, stock quantity, and a barcode. And each tag is opened and closed, just like in HTML. So here's a side-by-side comparison of JSON and HTML formats. And I would say that JSON is more common today. XML is slightly less common if you're using modern systems. So what we actually have here is the same data, but it's been laid out. And I found this graphic online. It's been laid out in the 2 different formats. So XML, we have open tag emp info for employee info, and the same here, we have a open curled brace and then the first key here. Now inside that we have 3 Star Trek characters with a name and age key value pair, and we have the same over here. Okay, now one thing to note is that XML is slightly more characters in XML, and I'm guessing if you were to take this up to very large scale, there might be some slight impact on that, although it's not something I really know that much about. So an API, what is an API? So an API is a computing interface that defines interactions between software intermediaries. So many large software companies have an API that you can use, a public API. Now, why would a company offer an API? Well, they would offer it so that you can use it in your systems. So, for example, Google Maps has an API. Facebook have an API. And the reason for that is it's quite common to want to get into Google Maps and look up a map. And if every time you had to look up a map in Google Maps, you had to send them an email or a letter in the post, and then they were going to take a screenshot of the map and post it back to you, that would be very slow. So what they actually do is they offer an API, they expose an API to the internet, and they say, if you send a GET request to our API server, we will reply, or our API server will reply. So it lets your computer system talk to their computer system, and they don't have to be there to monitor it. So I've got here a list of some publicly available APIs on this website called apilist.fun. So there's a meme API here. There's a cat facts API. Some meme generators. There's a Lord of the Rings API. More cats APIs. Pictures of cats from Tumblr. US restaurant menus. Ordering a pizza API. Random pictures of dogs. Quite a lot of silly APIs, but these are all publicly available. So Quora is a place where questions are asked. Facebook have an API. There's a random facts API. Open weather map, Spotify web, a news API. So there's some different APIs that are publicly available that we could use, and we would be able to send requests to, and they would send us something back. So how does this actually work in practice? Python has a library called requests, okay? And we can just install requests by running pip, which is for Python install packages, and then run install and requests, okay? Once we've installed requests to the local machine, okay, this is a library that lets us make requests. We can then just import it into our Python script. Now, we're going to use this requests library to send a request to an API so that it will reply to us, hopefully. So what I've done is I've created a variable here called response, and I'm going to use the assignment operator to assign inside a requests.get here. I'm going to supply the URL of an API called OpenNotify. Okay, and then what I'm going to do is I'm going to print out the response status code from that API. So let me just run this just now, and we'll comment out the other things so we just see what happens here. So let me just run this. Okay, so what we're getting back is a 200, and hopefully, if you recall, when we looked at managing a web server, 200 means success, okay? 400 means something else. Now, to demonstrate this, let me just put some bad characters in. Let's put a few ones in that URL there, and let me run this again, okay? I'll clear the terminal over, and let's run this one more time. Okay, so now we're getting a load of traceback calls, line 60, bad things have happened. Okay, look at all this. It's not happy at all. Words like failed to establish a connection. Now let's take these ones out and let's run this one more time. Okay, now we're getting a 200 success. Right, let's see. So that's all very, that's all well and good if all we want to do is see request status codes update. But let's actually see what the API is sending us back. Okay, so we can turn this one off and let's have a look at the response, and we're going to get the response back in JSON. So let's run this. So here we go. So the API is replied with, and it replies with this strange, this is just nonsense data that it's made up. Something about Sergei Kud Sverchkov I don't know what any of this stuff is, Mike Hopkins, but that's showing that's working. Okay, so that's a good way of just testing, and it shows you how simple it is. Literally, apart from the import, we have one variable that we get and one print statement that we respond. So, okay, so that's very good if we just want to use nonsense data. But what I have here, okay, is another API called postcodes.io. All right, so let me just copy postcodes.io and let's go and have a look at postcodes.io. Postcodes.io is a UK API that allows us to access open data about postcodes. Okay, now there's the address of the API, and what it's telling you here is if you send a GET request to this address and you add in a postcode there, what it will do is it will reply with information about that postcode, and it'll do other stuff like it'll give you the longitude and latitude. If you sent those, it would reply with a postcode. What you can send it, a postcode to validate, see if it's valid. You can check for the nearest postcode to another postcode. So all sorts of postcode related API fun with this. So let's look at the editor here. So the URL, as I showed you there, of the postcode API is api.postcodes.io/postcodes, and then we have to put a postcode in here. So I randomly picked a postcode NE49EN, and that's in Newcastle in the northeast of England. Newcastle 49EN. Okay, so we're going to send the request.get, we're going to send it this URL. And let's just see if the API will reply. So let's have a look at this. I'll just comment these out as well so Python doesn't get upset. So let's run that. So there we go. There's a 200 status code. So this is working. So let's see what's actually coming back when we send this postcode, NE49EN. Let's run that. Okay. So we've got a reply here in JSON, and it's telling us that this postcode is in England, the NHS area northeast, the longitude and latitude of the postcode, the European electoral region, the primary care trust, the town, the parliamentary constituency, the admin district, the NHS area, some parish information. So lots of information coming back from the API. So let me stick another postcode in here. Okay, let's do Edinburgh postcodes. Let's see if we can find a quick postcode online. Let's look at find a postcode. It's funny, if you ever go on a hunt for a postcode, you can never find one. Let's go for Edinburgh College postcode. Here we go. So there's Edinburgh College's postcode, and that's in 46 Dalhousie Road, Eskbank, Dalkeith. So let's just fire that in there, take out the space, and let's run this. Let's clear off the terminal and see if the API will reply. Here we go. So look, this is saying it's now in Lothian, Mid-Lothian Community Health Partnership. The area is Newbattle and Dalhousie. The parliamentary constituency, Mid-Lothian East. So all that information is coming back from that API there. So if you imagine, if you worked someplace and you did a survey, for example, or you did some information, and you gathered postcodes, you might want to build some more information out of that. And using APIs is one way we can do that. So that's just a little demonstration of how APIs work. So I've added this to the end. This is a little example of how to use an API and some documentation. And that is the end of topic 3. Now, I'm just going to open up the lab for today, lab 4. So let's open this and talk about this now. So let's just get this to the right kind of level of zoom. And let's maybe shut down some of these other things here. Okay, lab 4 is about importing data. So what we're going to do is we're going to take data that's in a CSV file, which is a text delimited file. So we have items here, delimiter here, which happens to be a comma, okay, comma separated value file. It's very similar to a spreadsheet, but without any formatting. So what we're going to do is import this CSV file that I've provided you into R. So let me just open up R just now. And last week, I told you about setting the working directory in R using setwd. But now I'm going to show you a slightly more exciting way of doing that. The reason that we were doing set working directory manually is just to get used to using R and how it understands our computer. So on the Moodle, I've provided you with 2 CSVs. The first one is 100 sales records. So what we're going to do is navigate to where we keep our 100 sales records. Now, you might have a folder called R, you might have a folder called Untitled, Untitled, Untitled 1, something like that. So wherever you keep it. Now, I have had some indication that there are some issues if you keep the folder in the cloud on OneDrive. I'm not sure R likes that too much. So a local folder is definitely recommended. So now in the past, what we would do is up here in our kind of script window, let me open a new one, is we would do something like set working directory, and then we would type out the path. So set wd, and then we would be like, okay, so it's C:// you know, my computer slash, oh wait, I forget about Windows this way, isn't it? My computer / some path. Okay, so that's one way of doing things. I'm about to show you an easier way to do it now. So head down to the files area down here, and if we click on 100 sales records and tick that wee box there, we go up to more, right? We could just do set as working directory, and that would save us doing set wd up here. Okay, so let's go to this and click on it, and it's going to pop up with this little pop-up, and let's choose import dataset. Now what that's going to do is bring up this useful window, and what this useful window is going to do for us is it's going to let us see what the dataset looks like. Okay, not only is it going to let us see exactly what the dataset looks like, it's also going to give us headers here and the type of data that R thinks that this is. Okay, so in this case, we have some character data here. This is actually a priority, I think, high, low order priority. We have a double. A double just means a big number, okay, a big integer. So R's kind of guessed, it's taken its best guess at these for us. And if we wanted to, we could manually change how R sees these things just now. So we could change, for example, that to numeric type only, less specific than a double. What we could also do here is we could say, look, we don't care about the ship date. So let's just go skip. All right. And what R will do, it will regenerate, and it will change the type of that to skip, and that will mean R won't import that column. Okay, so this could be called a data set. This could also be called a data frame. Okay, this way that we can overview data here. Now, at the moment, we've got the first row as names ticked because the first row is the name of the column. But that's not always the case. The first row might be blank. So if that was the case, we could untick that. And what R would do cleverly is it would automatically name these numbers. And you can see it's now put region in as the first row. So let's leave that tick. Thankfully, this is a nice CSV. It's also common to get files that might be space delimited or tab delimited. Okay, so these are some common delimiters. Thankfully, this is a comma as well. Okay, now what we can do, okay, is it might be tempting to hit import here, but don't do that. Okay, what we're going to do is this little clipboard over here means copy, or we can just highlight this text here. All right, and then copy. Click that a couple of times as well, just for good measure, and click cancel. What we're going to do now is, remember we did this before, this is old now, let's forget about that technique. Put this in, and look, R has a nice, I'll get there, it's one of these, try number one, there we go. R has a library called readR, or readR, that helps it read CSVs, and look, it's nicely formatted the command for us to import this data, and it's even said, look, column skip, and it's said which column it wants us to skip. Now, we could write all this out by hand if we knew all of this, but why would we want to do that when R's done that for us with that tool there? So that's one of the first kind of things. Now, look, if we want to get help on, and let's say we did actually want to write this stuff out ourselves, we can just do question mark set WD, okay, and over here the help page will load up for set WD, and we could easily figure all of this out. But why would we want to do that when R's going to generate that for us anyway? So now that we've imported this data, okay, what I'm going to do is the lab takes you through the steps to look at the data type using type of and class, the data structure as well using str, and then we're going to start plotting out some examples of the data. Okay, so this is where we make use of this character, the dollar symbol. Okay, and the dollar symbol is actually called a selector, the selector. So what R actually lets us do is, here we have a variable that we've created from our data frame. We've imported the CSV, and we're going to pass that to the bar plot function. Okay, and the bar plot function will open with our brackets, and then inside the bar plot function we're going to pass this sales records variable, and then with the selector character we're going to select the column unit cost. Okay, now when you press the dollar character, you'll see that RStudio actually pops up with a little help, a little kind of inline help that lets you, choose the columns. It understands that you're about to select a column when you do that. Okay, so let me just turn off my pink pen here, scroll down a wee bit. All right, so we're going to learn how to look at the data and find out some summary information, summary statistics like the median, the mean, the max value, the min value. We can do that with the summary function. Okay, and then we're going to look at some other applications. Now, these square brackets, what they actually do is they allow us to do a search, okay, when we open the square brackets. So here, what we're doing is we're using the mean function. So the mean of a set of numbers, okay? The mean is just a type of average. We're going to look at this, the whole data set, and we're going to select a column unit price with the selector option, okay? Because it's got a space in it, it's just in quotes there. Then we are going to search inside that column, okay, for region being the same as Asia. So this is allowing us to do calculate the mean of our data set from the unit price column, but only if the region is in Asia. Okay, and that is the syntax on exactly how to do that. Okay, once we've done that, we're going to do some other examples. There's region is Europe. Then we're going to look at order priority, and we're going to show this is a double match, and we can join the matches together with the ampersand symbol. Then what we're going to do is we're going to display specific columns, and we can do that using an index range here. Comma just means all the columns. This means 1 to 4. Okay, so the lab explains how to do these things, and then how to use the table function to pass something to a table, how to use the bar plot function to pass the table function to pass a selected column from a data set. So what this is called in R, okay, is this is called a nested function. So we're running a function inside another function, okay? That's called nesting functions, all right? That is called the selector. That lets us select a column from within our data set. And once we've learned how to do some of these different operations on data, then we're going to look at some row and column operations in a bit more detail. And for that, what I've done is I've created another CSV file, and this CSV file is incredibly simple. Okay, here. I just made it up. It doesn't mean anything. I made it up. I made up 3 groups and imaginatively called them group 1, group 2, and group 3. And then I made up, well, I didn't make up these years. These years are real years. They existed. Hopefully we were alive for these years. And then I just put some numbers in here. Now, the reason that I made this data set up and the reason I made this into a CSV file is because it's so small that you can see the whole thing right now. This is the whole thing that you can see. There's no extra bits. And the reason for that is I wanted you to be able to run some of these functions like mean, median, and mode, and be able to use the double square brackets to directly get in to a data set and pull out a column. So for example, the mean function on this data set, which I've named df group, that's just for data file group. The reason being that it's about groups and it's a data file, so I've called it data file underscore group imaginatively. Let's say we want to pull out a column, we can do that with double square brackets here. Just like the single square brackets let us do a search, double square brackets lets us pull a column out, and that 2 there is the number of the column. Now, just be aware that in Python, indexing starts at 0. In R, the column count starts at 1. Okay, so it's the same as normal counting. We don't have a 0 offset. So run some functions on some different columns, and then once we've done that, we're going to kind of put a couple of things together and then generate a plot at the end. Okay, so that is lab 4. Now, this should hopefully bring together all the knowledge that we've built up over labs 1, 2, and 3. So if you consider labs 1, 2, and 3 to be sort of introductory stuff, learning how to use R, learning how to troubleshoot common problems, lab 4 is importing data and putting it all together.